Okay, so here is what we will be doing today, and we'll be doing our homework that was on scientific notation, exponents, radicals, and probability. And then we'll actually be doing a review of the homework because I find that there's some of the problems that we need more of an explanation for, okay? So let's go into our homework. I'll bring that up on the screen. Okay, do you see that homework on the screen?
Yes.
Okay. You see, starting with number 1, right?
Yes.
Hello, Maureen. Maureen, you're on mute. Maureen, you're on mute. Maureen, unmute yourself. Okay. Now let's get started on this one, Alvin. I noticed you missed these. I think you're getting your positive and negative exponents and the movement of the decimal point confused. So we're going over it again.
All right.
Now, scientific notation in standard form is A times 10 to the X. And the A represents the number that we said between 1 and 10, right?
Yeah.
And then times, that's multiplication. And then X, that's the exponent that represents the number of places you move the decimal point.
Okay, so you're gonna move it to the right.
You can hear me, Miss Barbara?
Now I couldn't hear you before, Maureen.
Oh.
I can hear you now.
I had to get Mikey to fix it because the microphone wasn't working.
Okay. So you on the phone?
No, yeah, on my laptop.
Oh, you're on your laptop.
Mikey fixed it for me.
Oh, good. Now Mercedes is supposed to be on. I don't know where she is. All right. Now, so we're just starting, Maureen. Maureen, you didn't send me your homework. What happened?
Oh, I was busy. I was a little bit busy.
Okay, well,
my hand hurt me a lot too.
Okay, I can understand that. Okay.
And it's swollen.
Oh, you're going for therapy, right?
No, I got to go to the doctor first.
Oh yeah, you need to go to, especially if it's swollen.
Yeah.
Okay, so we're just getting started. Scientific notation. And I was just we're going over this again because there seems to be some misunderstanding of this. So I put the general format, A times 10 to the X, where A represents the number that's between 1 and 10, times, we use an asterisk for the multiplication symbol, 10 to the X, where X represents the exponent and the number of places you move the decimal point. So now if we want to change from standard, and this right here is standard, right? That's a standard format. And we want to change that to scientific. Okay, so
that is 6. This is 6.3 to 10 to the power, and the other one B is just 63, right?
Well, we moved the decimal point to the right or left, Maureen?
To the left.
No, the decimal point is here. We move it to the right between the 6 and the 3. Because remember this, it has to be between 1 and 10. So we move it between the 6 and the 3. And Alva, how many places did we move the decimal point?
Okay.
We're right here.
Yes.
Let me make this bigger. And I want you to tell me, let's see,
let me see. 1, 2, 3, 4, 7 places.
I want to make
we move it 7 places?
Right, just a minute. I want to make that bigger. Okay. Say. Just a minute.
Right is, oh, I see. 2, 3.
Okay. Now, how many places did we move it, Alva?
7 places.
7 places, right? Because it's right
Yeah.
here, and we moved it between the 6 and the 3.
Yes.
And if we move to the right, is the power negative or positive, Alva?
If you move to the right, it is negative.
Negative, that's right.
Yes,
So
yes.
what would be the answer for this number 1?
Okay, it would be
Which answer would it be?
would it be
No,
D? D?
That, yes, that's right. It would be D.
Yes, okay.
I
That's
got
correct. Okay.
I got that, but I got the different way I thought it was. I don't know. It's left and right this time. Excuse me, yeah.
6.3 times 10 to the minus 7,
Seven,
right?
yeah. Yeah.
Okay, so that would be D.
Okay.
Now, we actually need to do some more of these because I want, see, we're changing from, because before we get to scientific to standard, we want to do standard to scientific. So I want to make sure you understand here. Now, one way of knowing which way you go is, you see this 0 right here? If this is not a 0, then the number will have a negative power. Yeah, I mean, if this is 0, if it's not a 0, it would be a positive power. You see the 0, the 0 in front of the decimal point. You follow that? Because I think there's some confusion as to whether it's a negative exponent or positive exponent. So
No,
yes, Alva.
I know when you move to the left, it's negative.
No, you're moving to the right here.
It's negative.
No, that's negative, right?
Yes, and you move to the left, it's positive.
That's correct. But when you're given a standard number, do you know whether you're going to have a negative or positive exponent? Can you look at it and tell?
Yes.
How do you tell, Alva? How do you know?
Because the minus, you have 3 minus there. 10 to the minus 8, 10 to the minus 7, and 10 to the minus 7.
But my question to you, what is it, Maureen?
One is 63 and one is 6.3.
But that's not what I'm asking you. If I give you any number in standard format, just looking at the number, do you know in scientific notation if the exponent would be positive or negative? And how do you determine that? In other words, I give you a standard number. Okay, let's go here. All right, let me okay. Now I just give you a number. Okay, 4, 5, 7, 8. Now you look at that number, you want to write it in scientific notation. Do you know if the exponent will be positive or negative, Alva? And then how do you know?
Okay, that I really don't understand.
No, what I'm saying
It will
is,
be positive, I know.
What is it, Maureen?
I don't know. It'd be positive because the numbers is smaller than 10.
Because it's what?
The numbers is smaller than a 10.
No,
Oh,
this
it's
is
greater.
this is
It's great.
4,578.
Yeah.
Yes.
And I want you to write it in scientific notation. So where's your decimal point in this number?
You put it between
Between
the
the 4
4
and
and
the
the
5.
5.
No, I didn't ask you that. 4,578. Where's the decimal point in 4,578?
It would go between the 4 and the 5.
No, I didn't ask you where it would go.
Oh, okay.
Look at this. Look at this number. This is
Uh-huh.
4,578. Where's the decimal point, Alba?
Oh, in front the 8.
No. Where is it, Alba? Where's the decimal point? There's
It
a
will go
decimal point here. Where would I put it?
You'd have to put it between the 4 and the 5.
No.
No,
This
a
is
comma.
4,578. Where's the decimal point in 4,000? Let me just put a comma here. 4,578. Where's the decimal point in this number? In 4,578. Where's the decimal point?
In front, behind the 4.
No, Maureen, that would be 4 points. The decimal point is behind the 8.
Okay.
What I
Oh,
said?
yes. Oh, yes. Mm-hmm.
That's
It's
what I said.
You didn't say that, Maureen. It's
Yeah.
behind the 8.
Oh, it's but I meant in front. But I caught everything behind. I know it was.
You were saying be in front of,
Oh,
between.
in front.
It follows the last digit.
Oh,
That's your decimal point. You don't have to
Oh.
put it there, but that's where it is. It's
Okay, Miss Barber.
4,578. Yes,
Oh.
Alba.
For us to remember now, I have to remember when you write in a letter and when you finish the paragraph, you put a 0. You put a decimal point, right? A point,
You mean a period?
a period, yeah.
Yeah.
A point is like a period?
Yeah, that's right. The
Okay,
same thing.
Okay.
It's like a
Yes.
period. So
Yes.
after the last, what we call significant digit, and the last significant digit is an 8. You have a
Yes.
decimal point. Now you
Okay.
know where your decimal point is, Alba. Now, where do you move that decimal point to get a scientific notation?
Okay, you're gonna move it to the right.
If you move to the right, you've got to put some zeros there because there's nothing at the right of it, right?
Yes.
So where would you move it?
You're talking number 1?
I'm talking 4,578. Where would you move the decimal point?
I would move it to the right.
You mean, so you would put it,
I would put it to
how
the
would you
left.
move it here unless you had some zeros? Alba?
You'd have to put 4 zeros, no?
No, because you're changing the value of the number. This is 4,578. Now, when you write it in scientific notation, the value should remain the same. So this is 4,578. So think about it. What number times 1,000 gives you 4,578?
Okay. It would be.
What number multiplied by 1,000 gives you 4,578?
5 numbers.
No, I want you to tell me the number. Okay, so I'm saying equal. And let me put in here, right?
Yeah.
And then I'll put asterisk. And I want to multiply that by 1,000.
Okay.
I want you to think about your place value. So what does n have to be that when I multiply it by 1,000, I get 4,578? What is n?
N is 4.
Yeah, 4 what?
4 multiply, no, 4, 0,
No,
4, 5, 7, 8.
where's your decimal?
Your decimal gonna go 3 places to the right.
So what is the number that I multiply by 1,000 to get 4,578? It's 4.578, right?
Okay, yes.
That's the number that I multiply by 1,000 to get 4,578. See, we're
Okay.
talking place values now, right? This is 1,000.
Good afternoon, Miss Barber. Good afternoon,
Hello,
everybody.
Mercedes. We're doing our homework and we're going back over our explanation of scientific
Okay,
notation.
I understand what you're saying now.
Yes, so that's equal to, let me just put this down here. Okay, so n times 1,000 is 4.578 times 1,000, right? Just like
Yes.
if this was 4.5, like if this was 4,000, well, let's say it was 4,000, then n times 1,000 would be 4.
Yeah, I understand.
Okay, let me just copy
4,
this all on the other side, so we'll have it all together.
500.
Okay, because I want you to understand place value. First of all, 4,578, the decimal point is behind the 8, even though you don't have to put it there. That's where it is, okay? Now, a number times 1,000 to give 4,578 is 4,578, right?
Yes.
Now, what is 1,000 as a 10 power, Alva?
1,000 to the 10th power.
No, 1,000 is what? 1,000. And I'll put equal 10. And 10 is raised to what power?
No. 10 raised to,
How many times do you have to multiply 10 to get 1,000?
10 1 is 10.
But how many
10
times?
times. 10 times.
No. What's 10 times 10?
That's 100.
What's 100 times 10?
That's 100,000.
No, 100 times 10. Just add another 0. It's just 1,000, right?
Yes.
See, okay, let me do this. 1,000 is 10 times 10 times 10, right?
Yes, ma'am.
10 times 10 is 100, and 100 times 10 is 1,000.
Okay.
But if we say a power, what power would that be, Alba? How many, excuse me, how many times did I multiply 10?
You multiply it 4 times.
How many 10s you see right here?
1, 2, 3, 4.
No, the multiplication. How many you see?
10 multiplied by 10.
That's 1 time.
Yes.
10 times 10, that's 2.
2.
And then 10 times 10, that's how many?
3.
3. So then that decimal point, I mean, that power would be 3.
3. 10 to the 3rd power.
10 to the 3rd, right?
Okay.
So we said 4.578 times 1,000. So that means this will be, let's just copy this. Okay. And I'm over here. That means 4.578 times 1,000 is equal to, we already said, we already have our 4.578. And 10 is raised to what? The 3rd power. So then we put our 3 here. See, now we have our scientific notation.
Okay.
All right. Did you follow what I just put there?
Can I ask the
Okay.
question?
Yes.
The 10 represent 0, like 30.
No, the 10 is just 10. 10 times 1 is 10. The number 10.
I
But
know.
it has a
One.
power, you know, 1, 1, 1. What do you do when you multiply? You add the powers. 1 plus 1 plus 1 gives 3. Remember exponent rules?
Yes.
You got it?
Because, yeah, but for example, look at the 1,000. So instead of put 1,000, say you have 21,000, the zeros will go for 10. So you put
Okay, you said 21,000, right?
then you put a 0. So you're going to put
21,000 equals
so it's
21 times 1,000. And 1,000 is 10 times 10 times 10.
yes,
Except, go
I
ahead.
thought the 30 represent the 10 represent the 30 for each 1,000. Like you get 10,000, 1 million. Those 3 zeros represent 10 represent them. I thought it was like that. That's what I'm thinking.
Say again what you're saying, Mercedes.
I'm saying I thought the 10 represent the 30 in the 1,000. And if you have 1 million, all the zeros, every 30, 10 is the place for it. Then you say you have 9 zeros, so it'll be 369. So you put 9 to the 10 power, 10 to the 9 power, because the 10 represent the 30. That's what I'm thinking.
Yeah, but that's okay, Mercedes, but you don't always have just zeros.
Okay.
Okay, that's why I put the 4,578, 4,578, and I said to convert that to scientific notation, that is 4.578 times 1,000. 1,000 is 10 to the third. So to convert that to scientific notation, 4.578 times 1,000 is 4.578 times 10 to the third. 10 to the third is equal to 1,000. All right, because the question I asked from the beginning is
you answered my question.
I did. Okay, the question I asked from the beginning, I asked Albert, if I gave you a number, do you know whether the power in the scientific notation would be positive or negative from looking at the number? And she says no. And I said, well, if you put a number like 4,578, then that number will have a positive power, because to get a scientific notation, you're moving to the left. Positive power, move to the left. All right.
Negative, right.
But now, and then I said, if you had a number, it's like here, say if you have 0.2543, right? Now, Alba, 0.2543.
Yes.
Converted to scientific notation. Will my power be negative or positive?
It would be negative.
That's right. How do you know?
Because you don't have a sign between the power and the amount of, what I would say, it's not like you would have a minus sign there.
No, 0.2543. How do you know the power is negative from just looking at the number?
I really don't know where I come up with it, but I just say negative.
Because this is because
Mercedes, how do you know whether it's positive or negative power for the scientific notation?
Is the number 1 is a 0 at the left side. Number 2 You said the notation must be less, not less than 10,
Well, between 1 and 10.
between 1 and 10.
Okay.
So because that's going to be a negative, if there's a power at the end of that, like you put time 10, you have to put the negative sign. Like I said, to the 6 power, you have to put a negative 6 power like that. Because
No,
it's negative.
you're saying too much. You said it right at the beginning. You see,
Oh.
Alva, you said it right at the beginning, Mercedes. You could have stopped right there. See, this 0. If there's a 0 there, and then
Yeah.
decimal point, then you know you'll have a negative power.
Yes, okay.
All you have to do is look at this. You have a 0,
Yeah.
negative power. If you had a decimal point, it wasn't a 0, just put a 0 there. Then you know it's a negative power. All right.
Okay.
So
Which
now
word?
you know your scientific notation will be negative. Yes, Mercedes, you had a question?
What number work you doing, miss?
No, I'm just going through explanation.
Oh, I thought you were doing number 1 and number 2.
No. Number 1, we'll get, I think we did it. Maureen told me the answer. But since some person set their homework in and they had this incorrect, I'm going through it because
Okay.
it's kind of obvious we need to do another explanation. You got it?
Yeah, I didn't get on right away because we have a thunderstorm and I was a little careful of the thunder. I don't want this in a school to do that when I'm near to the window.
Okay, now Alva, 0.2543. What would that number be in scientific notation? Decimal point is here. Which way do you move it?
You're gonna move it to the. Gonna move it to the left.
Then you're going to
No.
have something not between 1 and 10. Remember that number in front of the 10 to the power has to be between 1 and 10. If you move the decimal point here, you're going to have 0.02 something.
Yes.
That's not between 1 and 10. It's
Okay.
smaller. So where would you move the decimal point?
I would move it to the right.
Where? You want a number between 1 and 10. So where would you move it?
Between the 2 and the 5.
Very good. Right.
Yes. And the 5.
2.543. Then, and I'll put asterisk 10. You could put the time, but I'm putting the asterisk. Okay. Now,
So
how
the
many
power-
places?
The
how many-
power would be 3.
How many places did you move the decimal point, Alva?
I move it 1 place.
Okay. So what would be the power?
Move it 1 place. The power would be 3.
No, the power
The
is the
power-
number of places you move the decimal.
Oh, okay.
And if you
So
move to the right, it's negative. So what's the power, Alva?
the power is 2.
How many places do you move the decimal point?
1 place.
So the number of places
One,
you moved
no,
it
it
would
would
be
be
the,
1.
so plus or minus.
It would be plus.
To the right is minus.
Well,
Right.
I can't remember that.
To the right is minus.
Minus, okay. And
So
to the
what
left,
is
to the left is
positive?
negative.
No, to the right is minus or negative. Same thing. All right. So you're moving from this point to between the 2 and the 5. That's to the right. 1
Yes.
place. So what would be the power, Alva, on the 10?
It would be 7.
How many places did you move it? From 2 to from the 2 to between the 2 and the 5. How many places is that?
I would say you move it 1 place.
That's it. and to the right is negative. So what would be the power on the 10?
It would be, oh Lord,
One place to the
yes,
right, the
yes,
power equal to the number of places you moved it, which you told me was 1.
yes.
So what would be the power on the 10?
It would be 1, Mr. Barbara.
Plus
No?
or minus?
You're moving it to the right, so it would be a minus.
So a minus 1, right?
Yes.
So minus 1.
Okay.
Got it?
Yes, ma'am. I don't know why it's not sticking.
Yeah, a minus 1. And a minus 1 is 0.1, and 0.1 times 2.543 is 0.2543.
Okay.
Because 10 to the minus 1 is 1 over 10. So that's 1/10, right?
Yes.
1/10 of 2.543 is 0.2543.
Mhm.
We've got to go back to the place value.
Yes.
Okay.
That, you know what, kind of messing me up is the positive and the negative. But I know you always said the negative is to the left and the positive is the right.
Right. Okay.
That one stick.
Mhm. Okay.
So,
Let's see. I think I put it. Okay. Okay. So let's go back. Maureen, what did you say the answer was for number 1?
B.
So you moved how many places?
7 places.
So what's the answer?
Number D.
D. You move from here to between the 6 and the 3. Just count the zeros, 6, and then and that's 6 zeros, and the 6 makes 7. And since you moved it to the right, it's negative. So answer D. Alva, you understand why number 1 is D?
yes, because you count the zeros.
That's right. How many zeros?
1, 2, 3, 4, 5, 6.
And then you count the 6. That's how many?
7.
That's how you get the 7. And since you move to the right, it's negative. Decimal
Yes.
point now between the 6 and the 3.
And it's 3.
And
yes.
it's negative. So 6.3 times 10 to the minus 7.
Okay.
You know, Miss, I did D first, and then I don't know where I go change it to C, because I count the thing.
Yeah, I was looking at that and I say, what happened here? She
I
moved the
counted
decimal
it
point
right, and then I couldn't find the first paper. I put all the answers and start hurrying it to do it over when I get home, because I came home, say I'm gonna fax it off to you.
Okay.
Then I just slipped me that, oh my God, I did get the right answer already.
Yeah, because well, B 63, remember it has to be between the 1 and 10. 63 is bigger than 10. B is the one you could just eliminate right away, right? Because it says 63 times 10 to the minus 7.
I'm sleeping and trying to get the answer back, do it over again after I've done it already. Because I couldn't get the time to start.
Okay, so okay. All right, Alva. We're gonna practice. Well, we just did the 63.036063. So Alva, what is this one equal to? 0.0567. Let me make it bigger. Okay, Alva, what would that be as scientific notation? You see where your decimal point is.
Yes.
You see a 0 here, so you know you'll have a negative exponent, right? So
yes.
Where would you move your decimal point?
I would move it to the right.
That's right.
Yes.
And where would you put it? So you're moving it to the right. Where would you put it?
I would put it, I'm gonna put it between the the 6 and the 7.
No, the number has to be between 1 and 10. You'll have 56.
Okay.
Point. So where
Okay,
would
so
you
it's
move
with,
it?
you move it to the right
Yes, where?
between the 0 and the 5.
That's 0.5. Your number must be between 1 and 10.
Okay, so it's between the 5 and the 6.
That's right.
Okay.
5.67 times 10. And what's the power on the 10? How many places did you move it?
I move it 2 places.
And you moved it to the right. So what's the power?
The power would be 2.
Plus or minus?
It would be a minus.
That's it. Alva, you got it. Minus 2.
Just like a practice, Miss Barbara.
Yes, yes. Well, first of all, you said, well, I know it's a negative exponent because you have a 0 here.
Yes.
You have a 0 here, you'll have a negative exponent. So you're moving to the right. Your number here should be between 1 and 10. The only
Yes.
place you can move it and have it between 1 and 10 is between the 5 and the 6, right?
Okay. Yes.
And you moved it 2 places and you moved it to the right. So 5.67 times 10 to the minus 2.
Okay.
Got it?
Miss Barbara,
Mercedes. Yes.
excuse me 1 minute. I'm gonna turn on the AC. It's very
Okay.
warm down there.
Yeah,
Just a
okay.
minute. Yeah.
Mercedes, next problem. What would it be in 0.0042? We're just doing some samples here. 0.004238. What would that be in scientific notation?
So we have a negative car moving to the right.
Right, okay. So what's the number times the 10 to the power?
It would be between the 4 and the 2.
Okay, 4.238 and times 10. And what's the power?
To the negative 1.
How many places did you move it, Mercedes? Make
Should I
that
count with
big.
0, miss?
Just a minute. How many places do you move the decimal point?
Okay, 4. The negative 4.
Okay, so -4. Be careful now. The number of places you move the decimal point.
Guess what, miss? I wasn't sure if I should count those 0.
Oh, you have to,
Oh,
because you
boy.
moved it here, right? 1, 2, 3, 4. You moved it there. Alva, you see how Mercedes got 4.238 times 10 to the -4?
She moved the
Well, first of all, a 0 here means you've got a negative exponent, right?
yes, yes.
Okay, so you're moving to the right. So the
Yes.
decimal point is here. And between the 4 and 2 gives you a number between 1 and 10.
Yes.
4.238 times 10. And why do you have 4, Mercedes? Tell Alva why you have a -4.
That's I move 4 places to the right.
Yeah, she moved 4 places. Just count them. 1, 2, 3, 4.
Yes.
3 zeros in the 4, and that's the 4.
And once you have a 0.0, you know it's negative.
Well, once you have a 0 in front of the decimal point.
Yes, it's negative.
That's right. And if it's a decimal point and you don't see a 0, just put a 0 there. Okay. Because if it's not a 0, it'll be a number, like something between 1 and 1,000 or whatever. Okay. Maureen, the next one. What's the answer?
Okay.
What's the scientific notation?
I move it between the 5 and the 2.
Then you've got 15. Remember, your first number has to be between 1 and 10. 15 is bigger than 10.
Oh, Okay, between the 1 and the 5.
That's right. Between the 1 and the 5, 1.529 times 10. And what's your power?
1
Plus or
minus 1
minus? Minus 1.
minus 1.
That's right. Minus 1. Alva, you see that one?
Yes, ma'am. Yes.
Okay. Maureen, tell her how you got that.
So I put the, let's call it. I move it from between the 1 and the 5.
That's satisfied between 1 and 10, Alva.
Right.
Okay. Keep going, Maureen.
So then I get it to be 1.529 because just move it one place. I move it between the 1 and the 5.
Okay. And how did you get 10 to the minus 1?
Because I move it one place.
And you moved it which way, right or
Right.
left? To the right,
Right.
so negative
Right.
exponent. Well, you knew
Yeah.
it was negative anyway because there's a 0 there, right?
Yeah.
Alva, you okay?
Yes, Miss Barbara.
Okay.
I'm just making a little note to myself while you.
All right. All right. Let's just do one more like that. Okay. 0. Okay. 0.00986. Okay, Alva. Give me the scientific notation for that number.
Okay, it's okay, 1, 2, 3, 4, 5, 6. Okay, so you're going to
Where would you move your decimal point?
I would move it to the right.
Correct. Where would you put it?
How many places we're moving it to the right?
That's what you're
Did you
telling
say-
me.
Okay.
Alva,
Alva.
I'm quizzing you, not you quizzing me. Okay. now,
Okay.
where would you
I
put
would
it,
move-
Alva?
I would move it 3 places.
Okay, so where would you put it? Between what 2 digits?
I would put it between the 0 and the 9. No, the 9 and the 8.
That's right. 9
9 and the 8. Yes.
and the 8, and that's
Yes.
6.
Yes.
And you can put that 0 there. You don't have to, but we'll put it there times. And how
Yes.
many places did you move it?
I move it 1, 2, 3 places.
Okay, plus or minus.
It's a minus.
That's it, Alva. Very good. You moved it to the right, so it's a minus.
Minus. Yes.
All right, very good. You're getting it.
Yes,
Wonderful.
ma'am.
Okay, let's look at some that are not negative. Okay. Now we're looking at some numbers now that won't be negative exponents, right? Why? Because you don't see them as 0 point something, right? They're bigger than that. So Mercedes, what would be the first one? 74,627. What would it be in scientific notation?
Okay, it would be
Where is your decimal point?
between the 7 and the 4.
No. Where is your decimal point in this number?
Between 7 and 4.
No. Where is your decimal point in this number? 74,627. Where is your decimal point?
It's behind the 7.
Which
after the
one?
4.
Okay.
The one
So
right.
so your decimal point is really right here, right? So where are you going to move it, Mercedes?
To the left,
Okay. And where would you put it?
between 7 and 4.
Very good. 7.4627 times 10. And what's the power on the 10?
to the fourth power,
Because you moved it how many places?
4 places.
4 places. Alva, you see that?
Yes, Miss Barbara.
Maureen, you okay?
Yeah, Miss Barbara.
Okay. Now, Maureen, 3, 4, 5. Scientific notation. What is it? Make it bigger.
3 and 4.
Okay, so 3.45. Okay, times 10. What's the power of the 10?
1.
Where's your decimal point?
The 3.
Your decimal point is after the 5. How many places did you move it?
2 places.
So what's the power?
2 to the 10 to the power 2.
That's it. Not 1, right? You said 1. And 10 to the power of 2 is 100, right? And 3.45 times 100 is 345. That's how you can check it, right? Isn't 10 to the second 10 times 10? And that's 100. 3.45 times 100 is 345. Okay. Alva,
Yes, Miss Barbara.
I need you to do this one for me. Let me make it bigger. Okay, what would that number, 124,876, what would it be in scientific notation?
Okay, it would be 124.
Where would you move your decimal point? Your decimal point is right here behind the 6, right?
Yeah.
Where would you
yes.
move it?
I would have to move it to the left.
That's it. And where would you put it?
I would put it 1, 2, 3. Moving it to the left.
And where would you put the decimal point?
3 places you're moving it. So would you put it at the 4 and the 8?
No, no. Remember the first number, Alva, has between 1 and 10. If you put it between the 4 and the 8, you've got 124.
Okay, so it's between the 1 and the 2.
That's it. Very good.
Yes,
So you
yes.
figured it out. So it's
Yes.
between 1 and the 2. So it's 1.24876 and times 10. And how many places did you move it?
I move it 1, 2 places.
No, no. You
No,
here and you
1,
moved it.
2,
Just count all your
3, 4.
digits.
1, 2, 3, 4, 5 places.
That's it, Alva. Very
Yes.
good. All you had to do was just count the digits, right?
Yes, ma'am. So
Yeah,
is
1, 2, 3, 4, 5.
yes,
Got it?
yes.
Make that bigger. Okay. All right. Any questions now on going from standard to scientific notation?
Well, it kind of stick a little bit now.
Okay. Okay. And so,
Because I know.
so there are no questions going from standard to scientific notation.
Yes.
Because now I want to go from scientific notation to standard.
Okay.
Okay. Now I give you scientific notation. You give me the standard.
Okay.
Yeah.
So what? That
So-
is number. What? Which one you're doing?
No,
now?
this
Number
is,
two?
I haven't got the 2 yet. I'm going through an
Okay.
explanation from scientific to standard. Now, if your exponent is negative, you move number of spaces to the left. And if it's positive, you move it to the right. Okay. So now you want to write these in standard notation. Okay, Maureen, what would this one be in standard notation? 3.14 times 10 to the minus 3. What would it be in standard notation, Maureen? Maureen, are you
Good
there?
internet. Yeah, I'm there, listening, yeah.
Yeah, I want to know what is this scientific notations 3.14 times 10 to the third? What is it in standard? What would be the
Maybe
number?
314.
Well, if it's 10 to the minus, if it's a negative exponent, then you know you're going to have a 0 point something, right? So what goes behind the decimal?
3.
No, this is 10 to the minus 3.
Oh,
Mercedes, you know what it is?
B- you mean after the
After the decimal point, what goes behind it? We're trying to find the standard
3.
notation. No, not a 3.
zero, miss?
Keep going, Mercedes. You moved it 3 places. So what would it be? How many zeros?
30?
3 zeros.
Yes,
2
miss.
zeros.
And what goes next, Maureen?
3.
314.
Yes, 314. That's
So,
right.
miss, I don't know why, miss, sorry, I'm sorry, let me ask a question. I don't know why I keep thinking that when I say 10 is 30. That's what I
No,
have in
no,
my head.
because if you see 3 zeros here, but you also have a 3, right? So that means if it's a minus 3, there's 2 zeros. And then the
Oh,
3 makes the third, right?
yeah. Okay, so instead of put another 0, just put the 3. I got
Just put
it.
the 3. That would give you the 3 places. Because
Yes.
you right here, you move it here, that's 3 places, right?
I have the 3 places in my head, but I'm saying it's 30.
Yeah, but if you put another 0, that's too many, because now you're saying 4. This is not a
Yeah.
4. This is a minus 3, not
The
a
3,
minus 4.
the numeral 3 go in place of the next 0 that I have in mind.
Yeah.
Okay.
So if it's a minus number here, you have 2 zeros and then put the 3, followed by the 1 and the 4. Got it?
Yes. What do you call the standard? This is the
We're going
standard
from
notation to
scientific to standard format. Okay. See, this is scientific. This is the scientific 3.14 times 10 to the minus 3. The standard is the 0.00314. 314, that would be tens, hundreds, thousand, tens of thousand, hundreds of thousand. 314 hundreds of thousands. Now, Alva, what would this number be in standard? 5.7 times 10 to the minus 4. Well, we know we've got a 0 here. Tell me what else to write, Alva.
A 0 in front and behind. So
Now, what goes after the decimal point?
you're going to put 0.
0. How many?
Yes. 0.
0.
3. Another 0.
Okay.
Yeah.
All right. Now, this is 5.7. Now, what goes after that third 0?
314.
No, we're here at 5.7. We've done this
Oh,
one. We're at the second
okay.
one, 5.7. So what goes after that third 0? Here's the number.
Third. Yeah. What goes after the third 0?
It's right here. What is that, Alba? Right here. See my cursor?
Oh, so you're gonna put a point there, move a point?
No, you put the digits. What are the digits? They're right there.
It's you're gonna put zeros?
No, you put the
No, they're
zeros.
here.
You put the zeros, Alba. Now you've
Yes.
got 5.7 times 10 to the minus 4. You've
Yes.
put your 3 zeros. Now what digits go behind those 3 zeros? It's right here.
You're gonna put the 5 And
The
the
fi-
7?
That's it, Alba. That's
Yes,
it.
yes, the 5 and the 7.
5 and the 7. Because when you
Yes.
move from this decimal point to between the 5 and the 7, you're moving 4 places to the right, right?
Yes, yes.
So that gives you the 5.7 times 10 to the minus 4.
Minus 4.
Got it?
Yes. Yes, ma'am.
So your 3 zeros is right, but after that, then you put the 2 numbers that
Two
came in front of the
numbers.
10, the times the
Yes.
10. So
Okay.
5, 7.
Okay.
Okay, Maureen,
Yeah,
standard.
0.0.
What? It's a positive
Okay.
exponent.
You can hear me, 0.
Why are you putting a 0? Maureen, why are you putting a 0? This is a plus 3.
Oh, plus 3.
Yeah, so what would be the number? What would be the standard?
2867.
2, 8, 6, 7.
Oh, I didn't know that. Oh, I thought that was a minus.
No, that's 10 to the third. 2,
Oh.
8, 6, 7. Mercedes, is that correct?
I think there's a 0 missing. 2 0 missing. Point 0, am I right? No, no.
1, 0.
2.
Does this 2,867 translates to 2.867?
Yes.
Alva, would you say that's correct?
No.
Why? What's wrong?
Didn't you have to put zeros?
What's 10 to the third? 10 times 10 times 10 is what?
100.
3 0.
10 is 100.
And then times 10,
1,000.
and 1,000 times 2.867 is 2,867. So you know this is correct.
That's stand right there, miss.
Yeah, that's
That's
correct, right? Because you're moving it 3 places. 1, 2, 3. 2.867 times 10 to the third. That's standard format. You could put a comma there, but it's not incorrect if you didn't put the comma. That's 2,867. But 10 to the third is 1,000. Remember, we just went through that. 10 to the
Yes.
third is 10 times 10 times 10, and that's 1,000. 1,000 times 2.867 is 2,867.
Okay.
Okay, Alva, the next one.
This is 9.12.
Times 10 to the fifth. So
Yes.
tell me what to write.
So you're gonna move it 10 to the 5th. You're going to move it.
No, just write the number. You see, this is a number that gave this scientific notation. So you have 9.12 times 10 to the fifth. So just write your 912. How many
Yeah.
zeros, Alva?
3.
3.
Yeah.
So let's put 1, 2, 3.
Yeah.
Okay, because that would give you 5 places, right? 1,
Yes.
count your digits. 1, 2, 3, 4, 5.
Yes.
Very good. Any questions going from scientific to standard?
Standard. Oh, well, we trying. We trying, Miss Barbara.
Okay,
Miss
well,
Barbara,
the next number
Sorry.
2 and number 2, you going from
Hold
scientific.
on a minute. 1 minute, Miss Barbara.
Yes,
What
Mercedes.
you just did that is a part of the homework.
What we went through was just examples.
Okay.
Number 2, now I'm at the homework.
Okay, thank you. That's all
Okay,
right.
now expanded form is really the standard form that we just went through. All right. So, Mercedes, number 2, what's the answer?
I have answer B.
You had B?
That's what I said, man. So I hope I'm right.
Okay, let's put B. Maureen, what did you have?
What number it is?
Number 2.
1, 2, 3.
What's the answer to number 2, Maureen? What did you have?
I had C.
You had C.
Maybe wrong, yeah.
Alva, what's the answer for number 2? Maureen said C. Mercedes
For
says
number,
B. For number 2, you writing the expanded form is the standard form. You want to take this scientific notation and put it in standard form. So what would you have?
yeah, I did put the right because just a minute, Mr. Barbara. 1.
Right, the 79881, and you've got to put some zeros there and tell me what is your answer.
Number 2, where are you? Okay, given the
Expanded form, give the expanded form of the following scientific notation. Expanded form is standard, just like we just went through. Okay.
Okay.
So take this scientific notation and write it in expanded or standard form. What answer would you get?
I did it this morning. I picked C. I don't know if I'm
You
right.
had C, Maureen has C, and Mercedes had B. Okay, Maureen, why did you have C?
I put C because it tell you 7.9881 multiplied by 10 to the power 7.
So
So that's
C,
why I
how many places did you move the decimal point in C?
put the decimal point. Let's see. I think it 7 times. 1,
But
2.
Maureen, if it's a positive, Alva says C also. But if it's a positive power, then there can't be a 0 here. It would have to be negative,
Oh,
right?
I see.
So it can't be
Yes.
C.
Okay.
Definitely
Okay.
can't be C. That one you could eliminate because you
Okay.
got a positive power.
Yes,
If it were
ma'am.
C, that would be a negative power, right? So Mercedes
Okay.
is correct. She said B, 3, 6, 7. Count the
Okay.
digits. 3
Okay.
zeros, 881, that's 6, 9, that's 7 places. Got it?
Mhm.
So the answer B is correct. C is the one you should eliminate right away because you don't see a negative power.
Oh, yeah, because it's a positive. Yeah.
That's right. It's a positive, Maureen. That's it. So you could eliminate C right away. It cannot be C because C would have to have a negative power. You got it?
Oh, I see. Yeah.
Alva, you understand now why you wouldn't be C?
Yes, Miss Barbara.
Yeah, it's a
Yes.
positive. So you're going to be moving to the right. So moving to the right in B, you just count the digits 3, 6, 7. And it's a positive 7. Got it?
Yes, ma'am.
Okay,
So
now
it would be B.
B, that's correct. Now let's go to number 3. Number 3. And Maureen, read number 3 and tell me how you would solve it.
Okay. I didn't do that one anyhow.
Yeah.
Each page of a top secret report on aliens required 2 gigabytes of space. What is the maximum number of pages the report can have so that it can be completely stored on a USB drive that's whole 4 multiplied by 10 to the third power KBs?
Okay, so Mercedes, what kind of operation is this? What kind of math operation would you do for this one? Now let's just underline what we need. A page a page requires 2 kilobytes. So we need that. Correct? Because we're looking for pages. Now the 4 by 10 to the third kilobyte, that's what the USB drive holds. So if the drive holds 4 times 10 to the third kilobyte, and a page takes up 2 kilobytes, Mercedes, what operation would you use to find the number of pages?
Multiplication.
I do a division on that one.
Division.
Yes.
Thank you, Alva. Division.
Yes.
Mercedes, think about what you just said.
I thought it was the multiplication.
No, you got a drive that holds a certain capacity, right?
Yes.
And you got a page that takes up a certain capacity. So to get pages, you've got to divide the size of the drive by the number of kilobytes per page.
Oh, I know I wouldn't get this one so right, Mitch, because I was not sure how to do it, but I
I see.
See, you have kilobytes. Think about it. If you put it there, you've got kilobytes divided
I just
by.
saying it now. I just saying outside to catch on. You have to divide up to get the space to put in the 2 kilobyte.
Okay. So kilobytes divided by, and this is kilobytes per page, right? So that's a division. And that's how you get pages, kilobytes divided by kilobytes per page. So Maureen, what is the answer?
See?
That's it, 2 times 10 to the third. Okay, so you put the kilobytes, the 4 times 10 to the third. Let's just take that. Take the 4 times 10 to the third kilobytes and divide that by the 2. Let's put that here. Okay.
When I read it, I didn't understand something that you're gonna get. You want more, so you have to multiply 2 by 4. That's why I choose.
No,
B.
but what did it say? It says each page contains 2. What are you looking for? What is the maximum number of pages?
So what I should be thinking of, how much space I will get in the 4 times 10 to the third power kilobyte to put the 2 kilobyte.
No. You given a page requires 2 kilobytes.
Okay.
You're given a drive that holds 4 times 10 to the third kilobytes. You look at how many pages can I fit in this drive or on this drive. That's the division.
So I missed the drive already have some in there, right?
No, it didn't say that. Where did you see that?
No, I'm just trying to figure it out.
No, it says a page contains a kilobyte. All right. Okay. A drive can hold 4 times 10 to the third kilobyte. So how many of these 2 kilobyte pages can you put on this drive? That's why it's a division. How many pages can you fit on this drive? What's the maximum? Okay. It would be what the drive holds divided by the number of kilobytes per 1 page.
I misunderstood the reading.
Yeah, that's why you have to read these problems really careful, the word problem, because what they gave you, a page contains how many pages can you put on a drive that holds this amount?
Oh, yes, got you.
Now, I had this problem been given with some other things, you probably would have gotten it right. I think what got you is that maybe the USB drive and the pages, okay? Because if I gave you that a page requires 5 inches, a box has 20 inches. How many pages can you put in the box? You probably would have gotten it right, right?
Yeah,
And
yeah.
you would have seen clearly that it was a division. But it's the same kind of problem, except it's dealing with disk space. The drive is a potable disk.
Thank you.
Got it?
Yes, miss.
So what's the answer, Maureen?
Hey,
The answer is C. 4 times 10 to the third divided by 2, and that's times 10 to the 0, actually. And 10 to the 0 is 1. So the answer would be 2 times 10 to the
The
third.
third power.
That's it. That's the
Yeah.
answer. 2 times 10 to the third. So let's just put 3. 2 times 10 to the third. So that'll be answer C. Very good, Maureen. Answer C. Any questions?
Oh, thank you.
Okay. So be careful with your word problems. Read them
I
carefully.
worked it out and divided, but I didn't.
But what
I
happened,
guess-
Ava?
I don't know, I get 2.5 to the third power.
You divide 4 by 2?
Yes, ma'am.
Well,
I don't know where I get that.
4 divided by 2 is like half of 4, Alba. What's half of
Yes.
4?
2.
2. And you didn't see anything 0.5 here, right?
No.
And your choices, and it's
Yes.
not 2 because you have 10 to the third. When you divide, you subtract the powers. But 2
Yes.
is really 2 times 10 to the 0. And 3
Yes.
minus 0 is just 3, right?
Yes.
Okay, so answer C.
Okay.
Now, what happened on this one? Okay.
That's number 4.
Number 4, you had a table here. I just knew somebody would get the bonus. What happened, Mercedes?
Uh-oh.
Number 4.
Miss, what I did was I subtract
Yeah, you subtract. That's correct. So what happened?
3.7 minus 2.7, and I got 1.
No. This you can't subtract unless the powers are the same. Mercedes, remember when I told you that? This is 10 to the third. This is 10 to the fourth. You can't subtract.
Oh, I don't remember that.
They have to have the same power. Remember, to add or subtract.
Oh, Lordy.
Remember, Maureen? What would you do, Maureen?
Maureen,
Okay.
wake up.
1950. No, Mercedes is right. You subtract.
That's what I did too.
You
I
did?
subtract the 1950 from the 1900.
No, 1950 is bigger.
Yes,
Right, right, right.
1950.
1950 is bigger than 1900. It says how many more students were enrolled in 1950 than in 1900. 1950 is
Yeah.
bigger,
Yeah,
Yes.
the more
Yeah.
if they come after 19, after
right?
1900.
And okay, so 19, that's 1950. Let's do 1900.
Uh-huh.
Okay, 1900. Let's put that one there. Okay, so
I subtract.
what did you do, Ava?
I
33 up
subtract.
1900 is 3.7, Miss Barbara.
correct 50, Miss
No,
Barbara.
I'm putting it here. I just copied it over,
Yeah.
and that's 10 to the third. I copied it over, and then I'm just changing it. It's easier. Okay. 1950. What were you saying, Alva?
No, I said I subtract the 1900 from the 1950.
But you can't subtract. Remember, I said the powers have to be the same. This is
Okay,
10
so
to the
that's why I
fourth,
got
and
it
this is
wrong.
10. That's
Yes.
it. Mercedes did
Yeah.
the same thing. The
Okay.
powers have to be the same.
Yes, ma'am.
in order to subtract, right?
Okay,
So
yes.
what did I, Maureen, you remember what I said to do to make the powers the same?
Oh,
Mercedes, you remember?
subtract two. Subtract. If you
Okay.
add
I can't remember.
You remember what I said to do? Okay. Let me just put that one just the way it is. Okay. Okay. Okay, this is the dot there is used for the times. That's okay. All right. And I'll review what I said. You can change, you can decrease the number in front of the power and increase the power. Or you
Oh,
can,
I see.
all right. So you can decrease this. So what would that become, Maureen? 3.7, we want to decrease it. So it would be what?
Three,
0.37,
7,
right?
uh,
And what would be the power, Maureen?
10 to the power 4.
That's it. 10 to the power of 4. So this would be 10 to the power of 4. Let's just copy that. Now you know your answer, right? Let me line that up so you can subtract it. So Mercedes, let's just put a 0 here.
Miss, you put the point in front of a 3.
Okay. Well, that's, well, let me put an X here. So I'm using the dot right there for times, but let me just make it an X, make it, that's the times. Okay, and let's put the X here for the multiplication. What's the answer, Mercedes?
I don't understand the setting out yet, miss.
What part you don't understand?
You got 70. I didn't get it. You multiply 10 by 7?
No. When you add, isn't 2.7 the same as 2.70? They're the same. Only reason I put the
Oh,
O
yeah,
because I have 0.37. I just wanted them to line up so we can subtract.
So did you get 2.7 to the
What did you get,
What-
Alva?
I got 2.7 to the 10 to the 4th power.
No, this
Subtracting.
subtraction. It's subtracting. What's 0.37 from 70, Alva? 0.37 subtracted from 0.70. What does that give you?
Just a minute.
Mercedes, what did you get?
You said 0.37.
From 0.70. Maureen, you got the answer?
Miss, what should I subtract? 0.37?
0.37 from 0.70. What does that give you?
Okay, I did that part of it wrong.
270.
That's 2.0
Maureen, what did you get?
minus
Mental math. 7 from 10 is what?
3,
And
3.
3 from 6?
3.
3.
3.
So that's what it is, 33.
2.33 times 10 to the 4th.
Okay.
That's your answer. You couldn't subtract it as it was because the powers were different. You've got to make your powers the same. And I went over how you do that. Remember, I told you, you decrease the number in front of the 10 power to the power, and you increase the power. Or you could increase and then decrease. But in this case, we wanted it 10 to the 4th. So that's an increase. So 3.7, we move one place and increase the 3 to a 4. And now they have the same power and we can do our subtraction.
Miss, can you please write the sentence underneath the answer, please?
I'm sorry, what is it, Mercedes?
Can you please write the sentence I just spoke a while ago?
Right one?
Or you increase and decrease. Can the
Okay.
sentence just read, say, can you
Okay.
write it?
Okay. 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 So A times 10. And let me put that to the end. Okay, this is the general format of the scientific notation. All right. So increase A by 1 and decrease N by 1. Okay. So if I decrease A by 1, I increase N by 1. Now I'm using standard format where A in our case is the 3.7, right? So if I decrease this by 1, I increase this by 1. So we just put them both here.
Okay, that's why I didn't get it right.
And it may not be 1, sometimes it could be 2, whatever. But whatever you increase 1 by, you decrease by the same number, okay? So I could decrease decrease A by 1, increase N by 1. So this would be increase. Got it?
Okay, so
So 3.7, I went to move the decimal point one place, 0.37. That's a decrease. Then I increased the power by 1. 3 plus 1, 4.
okay.
Mercedes, is that clear?
I'm not quite sure. I'm looking at it like,
Well, increase, well, the number you can increase by moving your decimal point, right?
okay.
So I
move
went from
this part by
3.7 to 0.37. That's a decrease.
So when you move it, the decimal point one place to the left, that's a decrease.
That's a
right?
decrease because 0.37 is smaller than 3.7, right?
Okay. And when you move a decimal point one place to two places to the right, you increase.
That's an increase. If I go from 3.7 to 37, that's an increase.
I'm talking about 2.7. You move move a decimal point.
Well, I didn't touch the 2.7 because it's 10 to the 4th. I wanted to get the 3.7 to be 10 to the 4th so I can subtract it.
Well, you put as you have 2.70.
Yes, because I have 0.37. So in order to subtract, I need a 10 here. That 0 represents a 10, right?
Oh, so there. Okay.
Yeah, that's why I put the 0, Mercedes, because I have 0.37 and I have 2.7. So you can always just add a 0. That doesn't change the value. 0.70 is the same as 0.7. Got it?
Okay.
As you change 3.7, then you have to increase the fourth for the 10.
That's
power.
it. The power goes up, the number goes down.
Okay.
And by the same amount, if you move it 2 places and decrease it, you're going to increase your power by 2 places. Here we only did 1. We decreased by 1, increased the power by 1.
Okay.
It doesn't have to be 1. It could be any number. But the thing is, you increase the number by the same decrease of the power. The same number
So because of your increase, that's why you end up getting 2.33.
That because now, Alva, I have both my 1950 enrollment and my 1900 enrollment 10 to the 4th. Then I could add or subtract or whatever I want to do, but I can't do it when they have different powers.
Different powers.
Okay.
Yes.
The only way you could do it when they have different powers, you'd have to actually multiply 2.7 times 10 to the 4th, and that's 10 times itself 4 times.
Yes.
That's the long way. I mean, you could do it that way. 10 to the fourth is what? 10,000. 10 times 10 is 100 times 10, 1,000 times 10 is 10,000. So you could multiply it by 10,000 and multiply this by 1,000, subtract them. But that's the long way. I mean, that's another way of doing it.
Okay.
If you didn't want to work with these powers, you could expand this to 27,000 and this to 3,700 and subtract them. All right. And then you could have given me the answer in terms of thousands or 10,000s. Questions?
Miss, I'm looking at 2.7. Why would 2.7 become 27,000 and but 3.7 is not 37,000?
Well, 3.7 times 10 to the third. That's 1,000 times 3.7 is 3,700, right?
Third. Oh yeah, yeah.
Yeah,
Forgot
one
about-
is to the third, so that would be 3,700, whereas this one would be 27,000.
I forgot about the 10
Yeah.
power.
Okay, remember 10 times itself 3 times or 10 by itself
So,
4 times. 10 by
7
itself 3 times is what? 1,000 times 10, 10,000. Mhm.
So 4 is 1,000 and 3 is 100. 10 to the third power. I'm
10
talking.
to the third power is 10 times 10 times 10, which is 100 times 10 or 1,000. 10 to the fourth is 10,000, 1,000 times 10,
Okay.
right?
Yes, ma'am.
Questions?
Okay.
Okay, let's go to the next. So remember now, when you have powers that are different and you want to add or subtract, you must get the powers
The same power.
You
Yes.
must get them the same. And that requires taking the number in front of the times 10 to the power, either increasing or decreasing it, but increasing or decreasing the power by the same amount.
Okay.
Okay. It doesn't have to be 1. It could be any number. I just put 1 here to know that the increase of the number is the same as the decrease of the power.
Okay.
Got it?
Yes, ma'am.
Okay. Rationalize and simplify. Now, what happened here? Maureen, Maureen, you want to do this one?
I am
Which
embarrassed.
one?
This one, miss.
Number 5. Rationalize and simplify. So
Did
what
I
is,
get that one right, Miss Barbara?
let me see, Alva. I
I
don't think so.
Cause I did D for number 5.
Let's see.
But I-
You had, let's see, number 5. You had, no, you didn't have that one right, Emma.
Okay, because I was saying like 3 going to 9 3
Let's see,
times.
Mercedes, you didn't have that one right either. Okay. So, all right, let me, so what did you say, Alva? How did you,
No, I was saying like the 3 divided by 20 over 20.
I
okay,
do my, but I get deep for my answer, man.
So I was saying I was saying 3 going to 9 3 times. And
Oh.
3.
okay, now let's do our first step. Maureen, what did you say you got for number 5?
I got had D for mine.
D as in dog?
Yeah.
That's not correct. Okay, Alva, what's the first step? What's the first step?
Okay. The first step is the
What do you
3.
get?
The 3.
Well, no,
You
what's-
multiply 3.
no. What's the first step? You're rationalizing the denominator.
Yes.
So you multiply both numerator and denominator
numerator.
by what?
Um,
By the
Well, I
radical in the
multiply.
denominator, Alba.
By the 20, right?
By the square root of 20, Alba. That's your first step.
Okay.
Remember, you rationalize. I said rationalize and simplify. So you want to do your rationalize first. In other words, you want to make your denominator a rational number, correct?
Yes. Yes.
Okay, so we want to multiply both the top number
By the
and the
number.
bottom number by what, Maureen?
20.
Not 20, square root of 20, Maureen.
Square root of 20.
Square root of 20, okay. Mercedes, you with us?
Yes, miss.
Did you do that first?
No, miss.
What
I go
happened?
blank- I go blank again. Every time I get
Well,
to the, I
you,
can't
you,
believe
well,
I'm
you
doing
gotta
hard.
do the first step. Multiply, you rationalize, and that means you want to make that denominator a rational number.
It's top
You
or
want
the
to get
bottom.
rid of the radical. Yes, Mercedes.
I don't remember if it's the top or the bottom I should use. That's why I go.
No, you use, remember we said rationalizing the denominator. Where's the denominator located, Mercedes?
Oh Lord, at the bottom.
The bottom,
I'm not remembering that.
always at the bottom.
I'm not remembering the
So you multiply the denominator.
You multiply the radical in the denominator by
Yes.
both the numerator and the denominator. That's like multiplying by 1.
Okay.
With me? Okay, so once you multiply this, Maureen, what do you get for the numerator?
Really? 320s, right?
Square root of 3 times square root of 20. What is that equal to?
It's the square root of 3.
It's 9.
No. It's
3
just
multiplied by
square root of 3.
Okay.
And then we just put square root of 20. We'll simplify later, right? Okay, so square root of 3 times square root of 20 is just square root of 3 times square root of 20. Everybody with me?
Yeah.
Okay.
Can you repeat that? The square root of
Square
3.
root of 3 times the square root of 20 is just square root of 3 times square root of 20. Now we'll later simplify, but I just want to leave it just like that, okay? Now, Mercedes, what's square root of 20 times square root of 20? What did I tell you when you multiply radical by itself? What do you get?
I get 20. The
Let's get
radicand.
20. That's right, the radicand. Very good. Everybody with me? Alba?
Yes. Yes, Miss
Radical
Barbara.
times itself, just give the radicand. That's the number under the radical. So we have square root of 3 times square root of 20 over 20. All right. Now, Maureen, where do we go from there?
Okay.
Now we go to our simplifying. So what do we do, Maureen?
Okay.
How can we simplify?
Simplify by dividing.
Divide what? I don't see anything you can divide.
So
Mercedes, do you know how you simplify? Go ahead, Maureen. How do you simplify?
The number that can go into 20.
And what is that number, Mercedes?
2 and 10.
Neither one perfect square root.
5 and
Keep going, Mercedes. You got it.
Oh, yeah, man.
What is it,
not all.
Mercedes? 20 equal what, Mercedes? What are the factors?
5.
5. Time what? Mercedes, you're on the right track. 5 times what?
5 5 times 10, 5,
5 times what number gives you 20?
4.
Yeah, 4. You got it. Okay. So if you can factor 20 into 5 times 4, and 4 is a perfect square root, right?
Yes.
That means you can factor square root of 20 into square root of 4 times square root of 5, right? So let's just copy this. Let's see. Just, okay, I want to copy square root of 3. Let's put that there. Now, Mercedes, you just told me square root of 20 is 5. Well, 20 is 5 times 4. So square root of 20 will be square root of 4 times square root of 5. So let's just put that there. So that's the square root of 4 times the square root of 5. All right. And what do we have in the denominator? Just, we still have our 20, right? Let's put our 20 here. And that should not be on the line.
That's
Okay.
to work. Okay. Oh, I said, okay, I'm going to get this little part here. I was fighting to get. And I said, oh, Lord.
Okay. Now, Mercedes, you said 20 was 5 times 4. Those are factors. So that means square root of 20 is square root of 4 times square root of 5. Now, anybody want to tell me my next step?
Add all the numerators.
What?
Add up all the numerators.
No. Alva, do you see the next step?
Okay.
The
The
root of
next 5, 4 is 20, and 3,
5.
I would say 3 into what? 3 into 20 goes.
Nope, 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 nope. You're forgetting the obvious, Mercedes. There's something you can do there. What is it?
You're going
20
to find
equals 5 multiplied by
what
4.
Mercedes, you're
5, 4
breaking
is
up. What is it?
you're going to find out what number you can divide 3 into.
No.
Oh, no.
Maureen, do you see it?
I'm looking at it there.
What's the square root of 4, Alva?
2.
2.
Alva, not you,
Oh,
Maureen.
sorry.
2, Miss Barbara.
That's a 2. So you can take the square root of 2 here and put a 2,
Okay.
right?
Yeah.
Okay. Now do you see the answer?
The square root of
Mercedes, you see the answer?
2, 5. I'm not seeing it, Miss Barbara. That one is very tricky.
You don't see the answer?
Answer is B,
Maureen's got it. Tell them how you got it, Maureen.
because I add 5 and 2 is 7 and 3 is 10.
No, Maureen, you didn't do that. What did you do, Maureen?
I would say 5 trees 20, 5 trees 15.
That's right. Square root of 3 times square root of 5 gives you square root of 15. And then
Yes.
2 into 20 gives you 10.
Yes.
That's how you get B, Maureen, right? Maureen
Yeah.
saw the answer. She just didn't say how she got it.
Oh, wait, Miss, can I go right back there, please?
Okay, right here.
Yes.
Square root of 3 times square root of 5 is square root of 15. Just like we can
Yes.
break up the radical into 2 radicals, we can put
Yes.
the 2 radicals together, right?
Yes.
Square root of 3 times square root of 5. Let me just put this here. Okay, I'll just put this here so I don't have to go to the next line. So this becomes 2 and square root of 3 times square root of 5 is square root of 15. So let me just put square root of 15 here. 2 times square root of 15. And this is 15. All right. And this is all over what? Let me just underline that. And that's all over 20. Correct? I still have my 20 in the denominator.
Okay,
Okay. Now, 2 will go into 2 one time and the 20 10 times, right?
yes.
So, Alva, what would that become? So what would that be equal to?
It would be equal to 10.
15 over
Square
10.
root of
Square root
15.
of 15 over 10. That's right. Square root
Yeah.
of 15. Let's just copy that there.
It's a little bit hard to work out that way.
Okay. No, this one was the simplest one, but I wanted you to see factors here.
Yes,
Okay. Square root of 15 over 10, and that is answer B, right?
yes, ma'am.
Answer B.
That's number 5, right?
Yes,
Number 5.
that's number 5. So you had steps here on this one. You had to rationalize and then simplify. That's why I said rationalize and simplify. So you rationalize, go back through it, multiply top and bottom by the radical in the denominator. That's the square root of 20. So in the numerator, you just get square root of 3 times square root of 20. Radical times itself, just give radicand. So that's 20. Now, you have square root of 3 times square root of 4 times square root of 5. Square root of 4, perfect square root. That's a 2. Square root of 3 times square root of 5 is square root of 15. Now you have a 2 times square root of 15 over 20. And you could divide 2 into the numerator and you just get square root of 15, 2 in the denominator 20, and you get 10. Any questions on number 5? Questions?
I'm looking, I'm
We can work a
slowly
little more
getting,
on
I don't
that
know
one.
why.
Mercedes?
I'm slowly getting, I don't know why I can't kick this thing. I listen to you do it so well.
Now, Mercedes, let me ask you now, this first step, do you always do that first step? Multiplying both numerator and denominator by the radical in
I
the
didn't
denominator?
remember I don't remember whether I should use the denominator or the numerator. Like when you
Remember,
put
we
20
are
over 20.
rationalizing denominators. Remember, I said that from the
Okay,
beginning.
rationalizing.
Rationalizing denominators. Put that in your head. Keep it there.
All right, good.
Rationalizing denominators. So you
Okay.
take the radical in the denominator, put it over itself, and multiply. Got it?
Okay.
That's your first step.
Okay,
You got it?
yes. And then,
Once you do that, then you see, is it simplified? No, let me simplify it. So you've got a radical in the numerator, but that radical factors into 2 numbers, one of which is a perfect square root.
so
20.
that's,
5
that's
times
the
1.
why you put, that's the reason why you put 3, 5, and 4 upon 20.
That's right, because 5 and 4, Mercedes, remember you gave me those as factors of 20.
Yeah, yeah,
They're also factors of square root of 20.
yeah.
Square root of 4 and square root of 5, right?
And you still have to get the square root of 4.
That's it. That simplifies to 2.
And you come back down and put 3, 2, 5
And
over 20.
then square root of 3 times square root of 5 is square root of 15.
So say it again, miss.
Square root of 3 times the square root of 5 is square root of 15. You know, just like you take a radical and break, just like we took the 20 radical and broke it into 4 and 5, we can take the 5, the 3, and the 5 and multiply to get square root of 15.
Okay.
That's like the reverse. We can break the radical up into factors. We can take the 2 radicals and make them one radical.
Okay.
Okay. Square root of 2 times square root of 3 is square root of 5. Square root of 6 times square root of 8 is square root of 48. You can multiply the radicals just like you multiply factors. Okay.
Yes.
Questions on number 5.
So I'm going to look at the number 5 again because I clear up a little, my thoughts a little better.
Okay, good. Maureen, number 6. How do you solve number 6? Rationalize and simplify. Questions?
Sorry, Miss, is it raining in your barrel?
I'm sorry?
Is it raining in your barrel?
No, it's not raining
Cat
in Queens.
and dog down here in Bronx.
Really? This weather is
Yes.
something.
I just have to move away from the window. It's thundering.
Oh, we. Okay, number 6.
Yeah.
Okay.
I work it out. Is it C?
Okay, so you're answering from Maureen, right?
Oh, I forgot. I'm sorry.
That's
Miss
okay.
Barbara.
That's okay. You can answer for Maureen. Maureen, you don't mind her answering for you, right?
She can answer if you want to. No problem.
She said you can answer. It's no problem. But unfortunately, that answer is not correct.
Okay.
Okay. All right, Maureen.
Okay.
How would you solve this?
I do
2
the square
times the
root.
square root of 12.
2 square root of 12. I do the, okay, I multiply. I just can't remember about, I multiply 2 by 12 and 12 to 12. So much how you do the 3 and 20.
Yeah.
I do 2 square root. And then put square root 12 to bottom and then 2 to top and 12 to bottom.
You mean square root of 12?
Yeah.
Maureen, say square root. Now, don't just say 12. You multiplying by square root of 12 over the square root of 12, right?
Yeah.
Okay, so then we put this square root of 12. I think you can solve this one. Okay, so let's put the square root of 12 here. Okay, now everybody with me on the first step, right?
Yes.
Multiply the top and the bottom by the radical in the denominator. That's the square root of 12. You just
Yeah.
bring that down.
So you said 12 is
Yeah.
144.
No, Alba. No,
12
no,
multiplied by 12.
No, square root of 12 times square root of 12 is what, Alba? Okay, I'm going to the next page. Okay. All right. Okay, let's take the first one, Alba. 2 times square root of 12 is equal to what?
24.
No, you can't multiply a number by a radical.
Okay, so
That would just be 2
yes, you multiply
and
the
the square
12.
root of 12.
12.
That's it.
Oh.
2 times square root of 12 just be 2 times the square root of 12. Now we'll later simplify it, right?
Okay.
Okay, so you just put that 2 as a coefficient of the square root of 12. Got it?
Yeah.
Now, Alva, what's square root of 12 times square root of 12? Radical times itself
12,
gives you what?
excuse me, they multiplied 2 12s, that's square root of 12, 144.
No.
No.
What is the radical times itself? Remember, I just gave you that rule. Radical times radical. Same radical. What do you get?
12.
12. That's it. Very good. You just get the radicand.
Yes.
Square root of 12 times square root of 12 is just 12.
Yes.
All right. Now, that's not one of your answers, but you can simplify the square root of 12. And what does, give me the factors of 12, Maureen. 1 a perfect square. 3 and 4. That's it. Very good. 12 factors of 4 times 3. So it's similar to the other problem, right, Mercedes?
Yes, miss.
So what can I write the square root of 12 as? If the factors are 4 and 3, what
Yeah,
will I factor the square root of 12 into, Mercedes? What would that be?
Yeah. That would be 2 times 6.
Oh, 4 and 3. Maureen
Hold on.
already gave me the 4 and the 3, and that's what
I
we're
just
gonna
make a
root.
mistake.
Okay,
Oh, so the square root of 4 will be 2 then. That's
no,
what
no.
you asked.
What
That's what you're
other,
asking?
no, Mercedes.
Okay.
Square root of 12 factors into 2 radicals. What are they?
3 and 4.
Okay, so then that means I want to put square root of 4 and square root of 3, right? So let's put 4
square root of 3.
and then put the square root of 3.
Oh, look at 2 is 4.
I have put 12 underneath.
Okay, that's right. That's right, Maureen. So this is square root of 4 times the square root of 3. And that's all over 12. All right, Maureen, what's the next step?
You multiply the 3 by the 2.
No, Maureen. Remember, we just did it in the last step. What's the square root of 4?
It's 2.
2. So then this becomes
Yeah.
2 times 2, square root of 4, and then times square root of 3. Let's put the square root of 3 here. And that's all over what, Maureen?
Square root of 2 is square root of 2.
And that's all. What's the denominator? Still the 12. Right?
Yeah, yeah,
Okay. Now, what's 2 times 2?
4.
That's 4.
4. So that's 4. And the square root is what? Square root of 3. We just put that back there. 4 times the square root of 3. And that's all over 12. Now do you see your answer? Mercedes, you see your answer?
Okay,
I
yeah.
can't see all of it, miss. I can't see all the what number are we doing, miss? Sorry. That's number 7.
It's number 6.
Number 6.
Okay, so we're at 4 times square root of 3 times 12. Mercedes or Alba, which one? How would he simplify this? You see a number that can go into the bottom number and the top number?
Yes, Miss Barbara.
What is it, Alba?
The 4 can go into 12 3 times.
That's it. The 4 that goes into 4 one time goes into 12 3 times. So your answer becomes square root of 3 over 3. And what choice is that?
B.
Square root of 3 over 3. And that's answer. What answer?
What answer is that, miss? That number 7 work, miss?
6.
Number 6.
That was number 6. Square root of 3 over 3. That's answer B, right?
Oh, okay.
Answer B, square root of 3 over 3. Questions? It's very similar to the other problem. We still had the 4, right? Square root of 4 is 2. 2 times 2 is 4. Now you've got 4 and 12 with common factors of 4. 4 into 4 one time, 4 into 12 3 times. I'll say these questions. Number 6. First step. What's your first step, Alba? When you rationalize the denominator, what's your first step?
The denominator?
What's your first step when you rationalize the denominator? What was our first step? 2 over square root of 12. What was our first step? Just tell me in words.
You multiply.
Multiply what?
the bottom. Like you said, 12 into 12.
No,
Mm-mm.
12 into 12 is like division. You multiply your numerator and your denominator by the radical. That's your first step. And your
By
radical
12.
is in the denominator. That's the square root of
Yes.
12.
Yes.
So we took the 2 over square root of 12 and multiplied it by square root of 12 over square root of 12. So you multiply numerator by square root of 12 and denominator by square root
By
of
square
12.
root of 12.
So when
yes.
you rationalize your denominator, that's always your first step. Got it?
Okay.
Always. You only rationalize denominators. First step, multiply numerator and denominator by the radical that's in the denominator.
So the answer is B.
That's right. Answer
Oh,
is B.
3, 3, 3.
Square root of 3 over 3. That's your answer. Any questions on 6?
Yeah.
Miss
Okay.
Slowly.
Okay. Mercedes. Now I think you can do number 7. Right, Mercedes?
7.
Not sure yet. I'm looking. I'll
Okay,
try.
it's still rationalizing. So, and you know your first step. So let's try. Okay, you taking 7 over the
7.
square root of 3. Okay. Okay, Mercedes. So what's your first step?
We're going to multiply denominator and the numerator. So you get radical 3 over radical 3.
So what's my first step?
Multiply denominator 7 times denominator and the numerator.
So what do I put in the numerator?
Radical 3.
You throwing away the 7? I have
Oh.
7 times.
Oh, you have to rewrite that.
7 is
times
there. So I put the square root of 3. You're right. Square root of
and the
3.
square root of 3.
Okay, so I put square root of 3, multiply the numerator,
The square, yeah.
and then you multiply the denominator by the square root of 3. Okay, so this is
I did that one, and I don't know if I'm right.
you.
I got A. Is it A?
I would get, I had 7
Okay,
square root 2 by square root 3.
all right.
Uh,
Okay, so
I
let's.
would get my wrong here.
Okay, so what do you get in the numerator? Mercedes. Mercedes is doing this one. What do you do it? What do you get in the numerator, Mercedes? 7 times square root of 3.
You're gonna get radical. You're gonna bring back radical 3, the radicand 3.
No, numerator.
Oh,
What do I get here?
you got 7 times radical 3.
7.
Yeah, 7 times radical 3. That's all right. 7 is the coefficient of radical 3. Okay, so that would be 7 times. So what do I get in the denominator, Mercedes?
You're gonna get radical 3. Radical 3.
You get what?
Am I calling it right? Radical 3?
Okay. Radical 3 times radical 3 gives what?
Radicand.
The
Radical.
radicand 3, just the number 3. That's a
Yes.
different radical is you have the square root symbol. Okay. Okay, Mercedes, is that simplified?
No, man.
What else can you do then?
We're gonna multiply the denominator by the numerator.
Why would you do that?
Multiply the numerator by denominator.
Why would you do that?
The denominator multiplied.
We're trying to find a perfect square root for 3 and 7.
Those
So-
are Those are
So it's
prime
separated.
numbers. Neither one of them.
Oh, Lord, you're mixing them up now.
Yeah, so what's the answer? It's
Well, so
already
it's start with
simplified. So what's the answer, Mercedes?
C.
C. There's your answer. It's already simplified. That was one where you didn't have to do anything but rationalize.
I
And
realized.
notice I didn't say simplify. I said rationalize the radical.
Oh, you see what I mean now?
I thought when you read it, you would see that, oh, it's already
No, I'm
simplified.
not, I didn't even see, I'm trying to understand the rationalization and the radical difference with it, especially when they mix up together.
Oh,
I'm
you
trying to
mean
get
the
it.
simplification and the rationalization.
Yeah.
Sometimes you rationalize is simplified. Sometimes you rationalize, you have to go another step and simplify. It could be numerator, could be denominator. But in this case, when you multiplied by radical over radical, it's simplified. And the key here is that you've got prime numbers. They can't be rationalized or simplified into anything else. Got it? So that's your answer, C. 7 times square root of 3 over 3. Got it?
Yes.
So that one was, I thought that one would be pretty straightforward for you.
No, I didn't, Miss, I'm still trying to comprehend.
Yeah, but once you multiply that out, Mercedes, you saying about you, but 7 is not a perfect square root, right? And neither is 3.
Okay.
Correct? That's your clue right there. They are prime numbers, neither one which have perfect square roots. So you stop right there. That's it. Got it?
Okay. Yes, thank you.
Okay, so simplify. Alva, what happened here? Did you simplify?
You mean in 8?
Number 8, yeah.
Oh, did I get that one right? No?
No.
Okay. All right, Ms. Weber. See?
Okay. All right, Alva. I'll take you through it. Now, what's your clue here? I gave you a clue in this one. What did I say your clue was? There's your clue right there. Square root of 5.
Yes.
Now, that means that's your clue. You want to get square root of 80 and square root of 25 with a factor of 5, right?
Yes.
So you like halfway there. Okay, let's take 80, Alva. 80 equals 2 factors, and we want 5 to be one of them. What's the other one? 5 times what gives you 80? 5 times what number gives you 80, Alva?
5, 4 is 20. And 5.
Mental math. It's got to be a 2-digit number, right?
5, 4 is 20.
5 times what number gives 80?
Oh, 5.
80 divided by 5 is what?
40. 80
divided by 5. What number times 5 gives 80?
4.
5 times 4 is 20.
Yes, so 10 for
10 times 5 is 50. So you know it's bigger than 10.
8, 10, 80. That's it.
5 times what number gives 80? And it's got to be bigger than 10 because 5 times 10 is 50. So what's the number?
12, no.
5 times 12 is 60. So it's got to be bigger than 12. Keep going.
13.
65. It's got to be bigger than that.
Oh Lord, it's 17 then.
It's got to be.
You missed it by 1.
What is it?
You missed it by 1. She said 17, miss.
17 is 85.
It's too
Mm.
high.
I
Too
want
big. Wait, I'm listening to Alva. What's the next number, Alva?
Oh, Lord. I know,
you almost get it.
100.
No,
10
It's-
10 is 100.
Alva,
10
wait,
8
very
is
warm. Alva.
wait. Too many people
10
talking.
8.
Alva,
Yes, Miss Barbara.
you gave
10
me,
8.
wait, Alva, listen.
Wait,
Wait, Alva, you gave me 17. I said, that's too big.
Mhm.
You
yeah,
gave me 15. I said, that's too small.
that's
So
too
what's the
small.
number,
Think.
Alva?
Write them down.
Alva, 15
It
is
can't
too.
come back to me, Miss Barbara.
Wait, yes, it
No,
can.
no, that's easy, Alva. You're not
Wait.
thinking.
Listen to me, Alva. I said 15 is too small and 17 is too big. So
big.
what's the number, Alva?
17
In
is too
between.
small.
15
15
is too small, 17 is too big.
Big.
I'll
What's
say
the number?
16 then.
That's it, Alva. 16.
Miss Barbara, sometimes the brain.
Don't worry, Alva. You got it. Okay. Now,
It be the best of us, Alva.
very good. 5 times 16. You're doing good. Now, Alva, let's look at 125.
Okay.
Okay, Mercedes. 5 times what gives 125?
5 times what give 125?
Yes, what number times 5 gives 125?
20, what? 5 times 25 give you 20.
That's it. So now you've got some perfect square roots, right? 25 and you got 16. So let's just copy this. Now you've got your factors here, right? So Maureen, square root of 80 is what factors? What's square root of 8? Go to mute on those phones. Square root of 80, Alva, is what? Square root of what?
Square root of 80 is 516.
So it's square root of 16
4.
and times the square root of 5. Okay, so let's just put the square root of 16 times the square root of 5. All right, now Mercedes gave us 5 and 25, so this is going to be the square root of 25 times the square root of 5. So let me just, this was what, square root of 16, and this is a 5. Okay, and square root of 25, and that's square root of 25 times the square root of 5. Okay, so you can see your answer now, right?
What is the square root of
Okay,
5?
okay, Alva, I want you to finish this off. I think you can do it. Okay, we have 8 times square root of 5. What's the square root of 16, Alva?
32.
Square root of 16. Number times itself to give you 16.
16.
What number by itself gives you 16? Multiply it by itself.
16 by 16.
No. Listen to me, Alva. What
Oh,
number?
Lord.
Put your
What
phone
words,
on
sir?
mute or turn it off.
Oh, Jesus.
Alva.
Yes, Miss Barbara.
Square root of 16. What number by itself? Multiply it by itself and you get 16. A number times itself gives 16. What is that number?
16. 2 8.
No, by itself. That means
By itself,
like
16.
2 times 2, what is it?
2 multiplied by 2 is 4.
Okay, but we want to get 16. So pick a number, you can multiply it by itself and get 16.
8.
8
No,
times 8
pick
is 64.
Oh.
You know the square root of 16. now.
4, Miss Barbara.
That's
4.
it. 4. Very
right.
good.
Yes,
Very
yes.
good. You know, sometimes they don't come to you as fast. Okay, Alva.
But Miss
25.
Barbara, 1 second right there, Miss Barbara.
Yes.
Although we get 16 and 5 up there. You should have to break it down.
That's how you're
Have to
gonna
break-
simplify, because if you get them
Okay.
all on, if you get them all as coefficients of square root of 5, Mercedes, then you can add them, right? You can add the
Okay.
coefficient. So now, Alva, what's the square root of 25? Maureen, what's the square root of
Five.
25?
5, Ms. Barbara.
5, very good. Okay, so let's just take this now. Okay, now you have all your coefficients in front of square root of 5, right? Correct?
Yes, miss.
Mercedes, when you add the coefficients, what do you get?
16.
Ah,
Sorry.
8
Hold on a
plus 4 plus 5,
1 minute, Miss Bob. I'm sorry. I'm sorry. That's 17.
17. So when you add the coefficients, you get 17 times square root of 5. Okay. There's your answer. What answer is that, Mercedes?
The answer is,
D.
where are the answer sheets? Oh no. The
They're
answer,
right
oh, the
there.
answer is D. The answer is D. Let me see if I got
D
it right.
is in dog. That's right.
I got it.
Okay. So,
I miss
yes.
Honest. You see what you're doing here? I
Yeah.
am on that track, miss, but I couldn't finalize it. And I look at that, you know what? I'm gonna pick D for the answer. I figured that is the answer.
Okay.
Because I don't remember how to add, or get the last part to add it up. That's why you
Yeah.
told me I'm
Yeah.
choosing D.
But remember, I tell you, when you have something like this, look at the square root of 5 and say, well, can I get my square root of 80, my square root of 125 as factors of square root of 5? Sure. 5 times 16 is 80. 5 times 25 is 125. 16 perfect square root. 25 perfect square root. I have them with the same square root of 5, and so I can add the coefficients. 8 plus 4 is 12.
Oh, so you, that's my little problem there. So I noticed that you have 8 upon 5, 16 upon, no,
Yeah,
8 to
like
5
when you
square
have
root.
this, right?
Yeah.
Look at the two that don't have the square root of 5, the lowest number in this case, which is square root of 5, right? And say, well, 80 is a factor of 5 and what? 16, perfect square root. 25, factor of 5 and 25. 25, perfect square root. So now I can get them as coefficients of the square root of 5, and then you can add them, right?
Okay.
Yes.
That's it.
I had that answer.
You had that, Maureen?
Yeah, that was the only one I got on the side of my heart.
Okay. Now let's just quickly go through our probabilities. Now, let's say somebody gave me 52%. How did you get 52%? Somebody had 52.
It's not me.
Okay. So you take 2 red queens out, right? So you remove 2 red queens. How many queens in a deck of cards?
Should it be
4.
13?
There are 4, right? The standard deck.
I got to buy in a pack of card. I don't remember the card.
Aye. Okay. So no, there are 2 red queens taken out. The deck has 52 cards. What's the probability that a randomly dealt card from this author deck will be red? So how many red cards are in a deck of cards?
So 4.
Let's see. How many red cards, Maureen?
2.
In a 52 card
4.
deck.
4.
No, okay.
And the old
How
part,
many?
In a 52 card deck, how many red cards are there?
Oh, 13.
Alva, do you know how many red cards are in a deck of cards?
In each deck, you have 4 of
How many red cards? Red. How many red cards in a deck
Oh.
of cards? Alva.
Isn't it red Isn't it 4?
No,
13.
26, miss?
26.
Oh,
You have 13 diamonds, 13 hearts, 26
What's in
red
there?
cards in a 52 card deck, right? 26. I'm sorry, 52, not 53. Everybody following? You have 26 black, you have 26 red, you have clubs and spades, 26.
Oh, yeah.
You have diamonds and hearts, 26. So if you take out 2, how many do you have left? How many red cards left?
24.
24. That's right, Alba. So 26, let's just say 26 minus 2 equal 24 red cards left. Right?
Yes.
Now, if you took out 2, how many total cards do you have left? 2 from, if you take 2 out of the 52. Alba, how many do you have left?
You're supposed to have 50.
50, that's right. So 52, you started with 52 minus 2 equal 50. So possible is 24. We said probability equal possible over total. Possible outcomes over total. So divide that out. Tell me what you get. Divide the 24 by 50. I want everybody to do that. Tell me your answer.
Say it again, miss?
Divide the 24 by the 50. 24 is possible. That's how many cards are left, red. And 50, I'm sorry, this is 24 over 50. So possible, let me just go write it the way I had it, T-O-L. Okay, now substitute in possible. That would be 24 over your total and 50.
0.
So what's the answer? What is it?
0.48.
Okay, so what's the answer then, Mercedes?
D.
D is the answer, 48%.
Which one you doing? 9?
Yes, 9.
That's the only one I got right.
I had that right too.
You had it right?
Oh,
Okay.
gee.
So you had to find your red cards left because you took 2 out, right? So that left 24. And if you took 2 cards out, that's 50 in the deck. So possible over total, 24 over 50, and that would be equal to 0.48, and 0.48
Yeah.
is 48%, right?
Did
0.48.
I send it, Miss Barbara? No?
Did you have, I'm not sure, I have to look at it.
Okay.
Okay, 48%, that's your answer.
Yeah.
Questions?
Yeah, I think I have that one right.
Okay, so you have to be familiar with the deck of cards. You have half red, half black.
Yes.
Clubs, spades, black, diamonds, hearts, red. Okay. How many queens in a deck of cards, Maureen?
4, please.
4 queens, because you have 2 black queens and 2 red queens. Okay. All right, number 10, Mercedes, number 10. Read number 10 and tell me your answer, Mercedes.
Let's see number 10.
There you go.
Okay, number 10 say, in a ship of toys from a manufacturer, the probability that a toy is defective is 1/50. If Marie, am I calling her name right?
Yes,
Select
that's good.
2 toys from a shipment, what is the probability that both toys are defective? I'm
What
sure
would
I
be
did
the,
that.
what would be the answer?
Oh Lord, I don't want to give my
So it's
answer.
a toy 1 and toy 2. So 2 toys defective is like toy 1 and toy 2 defective. So let me just put that as an and. Toy 1 and toy 2 defective. All right, so when you have an and, you do a multiply. So if it's 150, what would it be, Mercedes?
Pardon me, say it again, please.
When it's an and, you do multiplication, the product rule.
Yes,
So,
yes, yes.
so what would this be? One toy is what? 1 over 50, right?
Yes.
1 over 50. And then you do multiplication, I said, right? So times 1 over 50. What is that equal to, Mercedes?
That's 100.
1 over 50 times 1 over 50, multiplication.
Oh, Lord.
1 times 1 is what?
1.
And what's 50 times 50?
50 times 50.
It's 100.
No, I didn't say add, Albert. 50
Oh,
times
oh,
50.
multiply. Okay,
Multiply.
200.
2,
Yes.
5.
The
What is
answer
what
is
what
D.
is it,
500.
Mercedes? Mercedes, what is
2,500.
2,500?
Yeah,
And
D.
that's answer what?
D.
D.
Okay, I
Yeah,
got
that right too.
And is the product rule. Okay. Answer D.
I didn't understand how to do this one, Miss.
Yeah.
Honest.
And remember, probability of your ands, you multiply.
Just guess it.
150 over 150 times 150. And the probability that both toys are defective would be 1 over 2,500.
So that's D.
That
Yeah,
was
D. I had
10
that.
is
Yeah.
D. You had that right, Maureen?
Miss,
Okay.
I don't want to work with time, but Miss,
I remember like
see how you did.
brother and then we
Okay, now we got the spinner problem.
Excuse me, Miss Barbara.
Yes.
Yes, after. Come in.
Okay. Okay.
I didn't got how you did it.
Okay. Maureen, read number 11 and tell me the answer.
didn't fit out this. Kelly spun a spinner, which is pictured below 35 times. To record her results in the table provided. What is the theoretical probability of the spinner landing on an orange section?
So how many places do we see on the spinner?
6 spaces on the spinner.
6. And how many orange?
13 orange.
How many orange? No. Theoretical. Theoretical doesn't apply to the table. It requires to the spinner.
Oh, two.
2. So what's the answer, Maureen? Probability of the orange would be what? It's just a simple probability.
That's 2.
Possible over total. How many orange are there, Maureen?
2.
2. What's the total?
6.
What's 2 over 6?
A third.
That's the answer. 2 over 6. And that's equal to 1/3. That's your answer.
That's number 10.
Yeah.
Because 2
11.
into 1 and 2 into 6.
Number 11, yeah. It says theoretical. Theoretical just refers to the spinner.
Oh,
Experimental would be the table. Got it?
So
2
that's
over
D, Miss Barbara.
So that would be D, correct.
I didn't understand how to do it.
Yeah. Just remember, theoretical is referring to the actual spaces
Okay.
on the spinner.
okay.
Okay, the actual colors on the spinner.
I know I would get that one wrong because I just got an answer because I
Yeah.
didn't sure how to do it.
Theoretical refers to the spinner. Experimental would refer to the table. Okay, and 2 over 6, that's equal to 1 over 3. So let's just put 3.
Did you say answer 9 is what? B?
So answer D here. would be the answer.
Yeah, I know, but answer 9 is what again, B?
48%.
Yeah.
Answer
And
9?
answer 9 was
Mine was
48% or D.
Oh, D.
D as
Okay.
in dog.
Yes, I have that
And
one
10
right.
was G. 11 is 1/3, answer D. Any questions on anything we've gone over?
No.
The second to last, no, the third to last one. I didn't understand or you get the answer.
All right,
I didn't answer, get the 150 over 150.
are you doing 11, Miss Barbara, or are you leaving
No,
it
no.
at-
Which one are you asking me about, Mercedes?
10, she got about 10.
Number 10?
So I know you get 150 over 150.
Well, 150 is the probability that a toy is defective. So
Oh.
the probability of toy 1 and toy 2 defective
Oh,
is the
oh.
product of the probability of each
of-
one.
Okay,
So 1/50 times, and that was given in the problem. 150. Probability that a toy is defective. Probability that if you select 2 toys, probability they both are defective would
The
be
same thing.
150
Okay.
times 150, which is what, over 2,500.
Okay.
Thank you.
Alva, you had a problem? You had a question?
No, Miss Barbara, I was asking if you're gonna finish up with
Yeah,
11.
we finished. We're done.
Yeah.
Just remember now, theoretical refers to the spinner itself.
Okay.
If I
Yes.
said, what is the experimental, the experiment where then you would use this. But you didn't see any answers satisfy these answers, right? No, because they say 13 orange and 13 over 35 is not equal to any of those fractions,
I
right?
know.
Okay.
Uh
All right. So we're going to stop here. I'll send you the session.
huh.
All right. And let's see.